Okay. Well, hi everyone. We are honored to be here and honored that you chose us over Bruce Mamjian's talk. My name is Peter Farkas, and I have my co-founder and CTO Alexei Palaschenko with me. And we are going to talk about a very interesting topic. And I assure you that this is not going to be a FerretDB sales presentation. We are going to talk about moving MongoDB workloads to Postgres. And what we are going to talk about first is why. Just a quick intro. So FerretDB is a small startup. Our founders are Alexei Palaschenko, who's here, Peter Zaitsev, who you may know as the founder of Percona, and myself. We all worked at Percona at some point, and then at various other companies, all connected to data. So the agenda for today. Why move MongoDB to Postgres? Why on earth would you want to ever do that? What is the reason you would want to consider moving MongoDB anywhere, especially to Postgres? This is due to MongoDB's licensing. And then we are going to talk about the history of SQL as an open standard, just to put things into a bit of a context. Then we will mention the MongoDB query language as a possible new open standard similar to SQL. And we are going to talk about FerretDB a little bit and what it can do and how it does what it does. And then we will have a short conclusion on what was mentioned. So let's talk about databases and the popularity of different databases. This is the 2023 Stack Exchange Developer Survey. And if you take a look, you can see that Postgres overtook MySQL on this very list compared to 2022, which is great to see. But there is something else very important on this chart. Can someone tell me what is weird about this chart? What is something you don't like about this chart? Well, I can tell you what I don't like about this chart. What I don't like about this chart is if you take a look, Postgres is an open source database. MySQL is an open source database. SQLite is an open source database. And these first three databases are relational databases. And then the very first document database on this list is MongoDB. And I'm going to explain to you why I'm bothered and why we don't think that is open source. So whenever I give a similar talk, at this point, someone would raise their hand and say, wait, isn't MongoDB open source? Well, no. So the weird thing about this chart is exactly that the only document database among the most popular top 5 databases is actually proprietary. MongoDB started out as an open source database, so that is the source of the confusion. They adopted the SSPL license, and among many other things, the SSPL license says that if you run MongoDB as a service or as part of a cloud-based service, then you may need to SSPL your entire stack, which supports the service you're providing, which is not compatible with open source licenses at all. So why do we want to move MongoDB workloads? Why don't we just move to Postgres? Because as Postgres users, developers, enthusiasts, you may think that, okay, there is no reason to use MongoDB at all. Well, there are a couple of reasons. First of all, MongoDB has a large ecosystem. So MongoDB is a very, very easy to use ecosystem supported by a number of different frameworks, supported by most things JavaScript developers would use. And these tools depend on MongoDB to work. So if you don't want to rewrite the entire stack, which a JavaScript developer would prefer, then you're pretty much stuck with MongoDB. So now that I summarized our concerns over MongoDB and the licensing, I will go into a bit more detail later, but I want you to listen to this short story of SQL itself, because there are very interesting similarities between the story of MongoDB and the story of SQL. And this is by far not going to be a historically accurate and whole presentation on the story of SQL, but probably would be enough to illustrate the problem the database industry is facing. So the short story of SQL, this is actually a great slide from Yugabyte's CEO, and I really like it because it shows the first iteration of the relational model and the first foray into establishing the relational model in the world of databases. It was actually done by a guy named Edgar Codd. He worked at IBM Research Labs in California, and he came up with the relational model, which probably we all know on this conference. And it was a huge departure from the tree-based database architectures at the time. However, there was one big problem with the relational model, is that Edgar Codd was pretty much a mathematician, and the query language he suggested for relational databases, or the first version of the IBM's implementation of a relational database, was pretty much you having to write an entire program just to query something from your relational database. And two other researchers at IBM recognized that no one is going to use the relational database if there's no easy query language associated with it. So at IBM, there were two other people, Don Chamberlain and Ray Boyce. They came up with SQL, the query language which we all use and can use pretty much anywhere we want. It's a very sad addition to this story that Ray Boyce passed away just a year after publishing his paper on SQL, so he never learned about the impact he had on the database industry in general. So IBM had a great relational database software and also an easy query language, so they started to sell these several washing machine-sized machines. And if you wanted to use SQL and you wanted to use a relational database, you pretty much had to buy it. There was no alternative. And it did not run on anything else. That was the only implementation of SQL. So if you liked SQL, you had to use IBM products. And then, since the relational database was a success, at least for IBM, other vendors started coming up with their own implementation of the relational database and SQL, such as Informix or Sybase or this very unknown relational software systems Incorporated, which a couple of years after rebranded itself to Oracle, which might be more familiar. So the problem with this whole situation with the different implementations of the same thing is that these were actually not implementations of the same thing. So they implemented the SQL query language, they implemented the relational model, but they were not compatible with each other. So there were many different dialects and no conformity between these products. If you used IBM DB2, if you started out with that, you were kind of stuck with it still. So it's only when SQL became an open standard in 1986, 1987, that's where the whole success story of SQL started, and that's where all vendors could start following a standard which enabled users to learn SQL and then apply those learnings when operating many different implementations of relational databases. However, these vendors were still proprietary, all of them, so this still meant a degree of vendor lock-in. And since personal computers and servers and information technology in general became more accessible to smaller companies and the general public, that's when open source projects started implementing SQL, such as Postgres, which did not support SQL until 1994, 5 maybe, not sure. And since then, there are hundreds of derivatives of these products. So we may think that this is something which could happen in the 70s and that's behind us, but actually it happened again. And I think you understand now where I'm going to get here. So history repeats itself. If we take a look at document databases, there was this company called 10gen, which was later rebranded to MongoDB, which released MongoDB as the first easy-to-use database. I mean, everything is relative, right? And they came up with an even simpler query language to interface with a database. Of course, this was not a relational database, but a document database. The tagline was that you don't need to be a DBA to run a database. It's aimed at developers who don't want to care about schema, who don't want to care about the database itself. They want to implement everything on the application level and then let the database do its thing. However, after it achieved market dominance in 2000, starting at 2014, 15, they went proprietary. So they adopted the SSPL license, and they also tried to redefine the meaning of open source with the SSPL license. They still claim that it's an open source license, but it's very far from that. And this slide shows you a familiar situation. So this is the exact same slide as we had with the relational databases, but with document databases and MongoDB alternatives out there. So the moment MongoDB went proprietary, many others came up with their own implementations of the MongoDB API and the query language, and we are in the exact same situation where we have sort of kind of alternatives to MongoDB, but none of them are really compatible with MongoDB, and none of them are compatible with each other. These are all great products, but similar to the early implementations of relational databases, they cause lock-in to the user. So once you choose one of these, you're probably stuck with that. Some other issues with MongoDB alternatives. So if we think about an alternative, it inherently means that an alternative always needs to follow the real thing. An alternative always needs to think about implementing what the real implementation decided to have on their roadmap. So even though the query language is similar, but the feature set, the compatibility, the performance is very different from the real thing. And also, if you look at the alternatives, one slide back, you may notice that all of these alternatives are sort of tied to a cloud vendor, like Amazon, Microsoft, Huawei, or Oracle. So the reason why we wanted to hold this presentation to you is because we think that we need an open standard. We need an open standard for the MongoDB query language and for document databases in general. This would look like the same way or similar to SQL, where there would be a standard feature set defined, how a query should look like, how a query response should look like, what is the base feature set. And this would ensure a similar degree of portability between products. I know that if someone migrated between MariaDB and Postgres, you may very much, not like the process itself, but still the query language at least is similar, and your expectations towards the database on the base level could be similar. Not the case with document databases. And as it stimulated innovation in the relational database space, we think that an open standard should also stimulate innovation, and many different derivatives of this open standard would appear, which would result in the situation we have with relational databases, where we have all kinds of flavors and all kinds of solutions to any problem out there. So this is the point where we wanted to talk about what FerretDB is. And now that you understand the why, let us talk a bit about what we did so far to make this happen using Postgres.
Yeah, thank you. So standard is great, but it doesn't give us enough good if there is only one implementation of the standard, which is proprietary, and therefore there is no even point to have standard. So we have a solution we built our own. It's called FerretDB. It's open source. And it implements the same API as MongoDB, and therefore now we can say, okay, that new standard we are going to develop is actually going to be used at least by 2 different implementations. And of course, we hope that other companies will join. So what is FerretDB? FerretDB is MongoDB compatibility layer, which acts as a proxy before PostgreSQL. It's written in Go. It uses PostgreSQL as backend, obviously. You can run it anywhere on-prem or in cloud, and it's released under open source Apache 2.0 license. So you can do whatever you want with it. It's not like SSPL, of course, and also not like AGPL, like MongoDB was licensed before. So MongoDB compatibility means that existing elements of MongoDB ecosystem will work as is with FerretDB. You don't have to update your software. You don't have to update drivers, rewrite some part of it. It will work transparently as before. In most cases. Of course, there could be some edge cases that we need to investigate, but the promise is that. So all existing tools, frameworks, applications, drivers will work like that. So how that's possible? MongoDB actually not only ships MongoDB database itself, but they also ship drivers for all different languages they wrote themselves. For C++, for Java, for Python, for Go, etc. They are all licensed under Apache 2.0 license, and you can use them with MongoDB, and that's how your application doesn't fall under SSPL of the MongoDB itself. So what we do, we use the same drivers and the same applications written using the drivers, and swap MongoDB API and data layer. So instead of Violet Tiger that they use in current version of MongoDB, we use Postgres. And instead of MongoDB itself, we use FerretDB, our own solution. So as you can see, it's at 2 different components that could be scaled separately, and they communicate via network calls. So that's all transparent for the application, and also PostgreSQL sees FerretDB as just a regular client connecting to it. So why we choose Postgres? Well, I don't think I have to convince you to use Postgres at that conference, but just to explain why we choose to use that and not, say, MySQL. First of all, it's of course open source, and we needed an open source backend for our open source solution. It has a huge supportive community. It has great existing JSON capabilities that we need, and I will explain soon why we use JSON and how. A large number of users already run both PostgreSQL and MongoDB, and they would like to simplify the infrastructure and to run only Postgres without having a need to run MongoDB for some other existing previous applications. So strong interest from users with operation experience in PostgreSQL. They don't have to learn how to run both Postgres and Mongo. But we say about Postgres, actually, FerretDB could work with many PostgreSQL versions and forks and variants, such as Yugabyte, CockroachDB, Timescale. At various times, we successfully tested FerretDB with them. So let's talk about the current state of FerretDB, how it works, what are limitations, and all that. So currently it stores documents in indexed.jsonb columns, and that's why we needed good JSON support from PostgreSQL. We fetch superset of requested documents via SQL queries. What I mean by that in many cases, FerretDB could fetch more than strictly needed, and then we filter those documents in the FerretDB itself. So why we do that? First of all, let's see how we store documents, and that will help us understand why the way we query data. So in BSON documents, BSON is a standard MongoDB uses for storing documents. Field order is significant. In JSONB, order of fields is not preserved, right? You know that it's sorted by default to make it easier to index, to store, etc. But we need to preserve this information. Well, how we could do it? Well, we just add additional field in the document itself, and then we store the original order. That's simple, that's very straightforward, not very elegant, but that works, and that allows us to build effective indexes. Another interesting thing that BSON has more data types than just JSON. For example, it has 3 different types for numbers instead of just number as in JSON. It has additional types for, say, things like timestamp, which is not time, but separate internal data type. And of course, they have their own weird data types like JavaScript code with scope, which is deprecated but still needs to be supported in some cases. Okay, how we are going to differentiate that this number is short integer and this number is long integer? Well, we do the same trick. We just add additional method information to the document itself. And then again, so we always store the number as a floating point number, as double, but we store the original information in the document, and that allows us to do filtering by data type, for example. So how we query data? We need to compare BSON values in filtering and sorting. And what's interesting that relative to PostgreSQL, where if you have a query where v less than 42, you know that v is a number. That's not the case in MongoDB, because it could be also string, or even worse, it could be array on an object. And that should somehow work. So all these comparisons between objects, array, nulls, different numerical types, somehow work in MongoDB. And they actually work not in very straightforward way. For example, not a number is less than 1, which is obvious for some at MongoDB, I guess. Null is less than non-number. Empty array is less than null. Empty array is also less than array of single element null. So given that we know that empty array is less than null and empty array is less than array with one element null, how null and array of one element null compare to each other? That depends on the sorting order. And I'm talking about comparison. So comparison in theory should not depend on the sorting order, but in MongoDB it does. So that's we kind of need to either replicate as is or explicitly don't support and then return error in such cases. But there are many cases that are harder to emulate with PostgreSQL with its more strict data type system. So we uncovered that with integration tests. We write our own compatibility tests where we send the same request to both FerretDB and MongoDB and compare results. And then we can check that we get exactly the same documents as they in the same order. We run existing applications. So we use some existing open source application, run them with FerretDB, run with them with MongoDB, compare results. We run MongoDB own JavaScript tests. They have them spread across multiple repositories, but yeah, we run them and check what's not working and fix it. And of course, we have users, customers who are happy to report bugs to us. So with all the set of tests, we now know all the details about MongoDB queries, how they compare values and all that. So what we did so far in FerretDB 1.x. As I said, we in many cases fetch more data than needed and do the comparison and go. And thanks to our tests, we have all those details. We could make sure that we work the same way as MongoDB. Originally, we fetched all data, but then we decided, okay, we could actually remove support for some edge cases. I previously showed, for example, we just removed comparison between not a number and empty array because it doesn't make much sense. Then we write simple queries. We actually push down those queries down to the PostgreSQL. So for example, if you want to get the all documents where v is exactly 42, independent of the data type, but if it's number, that's simple enough. In that case, we get all the data we need. We don't need to do additional filtering on Go side. And that the way we stored information allows us to make indexes work. So as I described above, they fit quite nicely with existing JSON-B indexing support. But we could go only so far with that. We could always use more performance out of open source MongoDB alternative, and that how to move forward is not very straightforward. So we considered multiple options what to do in the next big major FerretDB release. We could continue generating more and more complex SQL queries, and that actually proved to be very hard. Writing code for generating these queries, testing it, supporting all those edge cases quite complex by itself. We could push some logic out of FerretDB source code into stored procedures in PostgreSQL, or we could use custom operators or custom data types, or we could go on in and make our own custom extension. So what we decided to do, we decided to go all in, and we are working on custom extension for PostgreSQL that would implement a part of comparison, sorting, querying logic of data inside PostgreSQL itself. So technology preview will be available about 1 month from now. Currently, it's not open source because things are changing quite a lot, but it's going to be, again, in about 1 month. So watch our social networks, I would say, or at least our GitHub repository. So we have a roadmap, it's public. Right now, the extension is not there yet, but it will be soon. And you can watch us and tell us what you need out of FerretDB, and you can affect the roadmap.
Give me the clicker. Thanks, Alexei. So as a conclusion, I hope, or we hope, that after this presentation, you also think, along with us, that there is a need for an open standard for the MongoDB query language. We think that MongoDB is going to be the same kind of commodity as SQL is, because that's what fuels innovation, and that's what enables others to interface with the different products and solve problems which MongoDB or other vendors did not ever think of solving. This would be the best outcome for the industry, for users, and everyone involved. A side addition to this presentation is that many times when we have discussions with the Postgres community, everyone gets very excited about the prospect that Postgres is going to be capable of doing yet another thing and serve users in yet another area, but there's no real understanding of the why. There's no real understanding of the fact that there are a large number of users who really want to use MongoDB, and they will not learn relational database theory or SQL even to move away from MongoDB. So the purpose of this presentation was to make a case for the open standard, which we are going to communicate very often about in the near future, and make a case for FerretDB to show the Postgres community that we are here to equip Postgres to do yet another interesting and probably a bit crazy thing for users. We do build FerretDB with the community, so if you're inclined to shape our roadmap or contribute to FerretDB, you're more than welcome to do so. We are also working with and constantly looking for Postgres providers, Postgres as a service providers, because FerretDB can actually turn their Postgres services into MongoDB as a service, which was not possible after the license change. And if you're not a contributor or don't feel like interacting with FerretDB, you can still do so with the document database community. One of our speakers was actually Bruce, who now speaks in the other room, I guess. And the reason we had him is because we want to connect the Postgres community with the world of document databases, and we want the Postgres community to drive innovation in the document database space. So if you want to give a talk, if you want to listen to any of the talks in the document database community, there are monthly, sometimes bi-weekly talks, and you can also submit your own. This is founded by FerretDB, but if your talk would be about why FerretDB is the worst idea you've ever heard, you would still be able to deliver that. We are impartial and we want to hear all opinions. Thank you so much for your attention today and for coming, and let us know if you have any questions.
And also let us know if you want some stickers.
Yes.
So it's an exciting product. So thanks for bringing this. So let's assume that I have a very large MongoDB instance and I want to move it to FerretDB. So how does this migrations will come into picture? So is it production ready or is it in still roadmap? The existing data present in my MongoDB.
Mm-hmm. Wanna take it? Or? Okay. So we very often get this question how the migration works between MongoDB and FerretDB. And since FerretDB is striving for MongoDB compatibility, basically you can use MongoDB Compass or any MongoDB tool just as if you would be migrating between two MongoDB instances. So, so FerretDB aims to make it available to users to use the tools they already use to manage their MongoDB databases. When it comes to big databases or complex workloads, we always suggest to first test with FerretDB before doing before making any commitment, because it can very well be that you're using a MongoDB feature which is not yet implemented in FerretDB. This is why the open standard would be important. So we are more than happy to help you with assessing whether FerretDB is for you. We do this because this actually helps us to shape our roadmap and decide whether a particular feature would be worthy of implementation.
Thank you.
Yeah, maybe a bit more specifically. So if you use MongoDump, MongoRestore, or MongoImport, MongoExport with MongoDB, that's also supported by FerretDB and actively being tested. So that's something we provide compatibility, and yeah, it works.
It's actually, I'm not sure if I have it running. I don't, but maybe during the next question I can figure out how to show it to you.
So my question is partially answered because that is what I about to ask, that for this database to have, I mean, what kind of a tool we have, for example, for backup or performing certain operations. So you said MongoDump will work with FerretDB, right?
Yeah, so MongoDump is the one we actively test. So it's a like of our integration CI pipeline. So it always works. But we also successfully used FerretDB with Percona MongoDB backup, for example. Okay. So yeah, all of that should just work. If nothing, yeah, if it doesn't work, create issue, we'll fix it.
Okay, so you're saying whatever tools used by MongoDB or the variant of MongoDB, those most likely will work with the FerretDB also. For example, let's say I wanted to connect the client or reading wall files. I mean, those kind of thing.
Yeah, in most cases, you can just swap MongoDB with FerretDB and application will not even know. Okay. If you implement everything. If you don't implement everything, or if performance is different, of course, you will see some difference. But for simple applications, that was the case for a long time. And now we are compatible with more and more complex applications.
So, are you planning any tools, FerretDB tools, just to perform any certain operations? I mean, or you are depending on upstream only?
So between MongoDB tools and PostgreSQL tools, we don't think there is a way for us to do something new, because you can also use Postgres tools to do import, export, backup of PostgreSQL itself. You can use Mongo tools.
There is nothing specific about FerretDB which you would need to use a separate tool for.
Got it.
So you either do it with the MongoDB tooling or the Postgres tooling in some extreme cases, but the whole point would be to not have users and database administrators learn yet another thing, but use what is already exists in the market. And this is not the best demo, of course, because it's very, very crude, but we have FerretDB and Postgres run in Docker on this laptop. Mm-hmm. And this is MongoDB Compass, I think the latest version. And as you can see, it connects to FerretDB without problems. It never noticed that it's not MongoDB, actually. And you can create a new database, a new collection, and then you can, back to your question a little bit, if this is your database, we all know that it's probably not 0.5 MB, but for the demo purpose, this may work. So, I take a JSON file, it says import completed, and now we have the data which MongoDB thinks it is in MongoDB, but in reality, this is Postgres, and it interacts with the database without issues. You can query, create aggregation pipelines, or whatever else you can think of. So this is our aim.
Yeah, perfect. Thank you.
Probably not. Maybe after the presentation, but it's accessible via Postgres for sure.
Why FerretDB, the name?
Why FerretDB? That's the best question out there. So first of all, it's very hard to find a domain name, right? If you ever try doing that's the worst thing about starting a project or the company, to actually find a name which is available. And we are not native English speakers, so we actually did not know this before going with the name. But we also found out that in English, to ferret out means to carefully search for something. And that's actually a great name for a database. So that's what we roll with. Also, if Postgres can be an elephant or Hadoop can be an elephant, then we can be a ferret.
Awesome. Thank you. Thank you, Peter.
Thank you so much.
Alexei.
Thank you.